given this function, determine the end behavior of the graph. Well, first off, it begins with a positive x to the fourth. Now, with an even degreed function, that means both ends point in the same direction, and since that's positive, both ends are going to point up. So I'll just write both ends up. List all the possible rational zeros. That means we've got to look at the factors of the 2 out front, which are 1 and 2, and the factors of that 21, which are, let me hold that down there, which are 1, 3, 7, and 21. Okay, so let's put each of these over 1 first. So that gives us plus or minus the set 1, 3, 7, or 21. Then each of those needs to be put over 2, which gives us 1 half, 3 halves, 7 halves, or 21 halves. So that is a set of 16 different possible numbers there that could be our zeros. Now find all the zeros of this function and state their multiplicities. Okay, let's start here. Let's test whether 1 is going to be a 0. We've got 2 minus 5 minus 17 plus 41 minus 21, and if you add those up, you do get 0, and that does say 1 will be a 0. Test 1, semicolon. So let's put 1 in. Let's write our polynomial, 2 minus 5 minus 17, 41, and negative 21. Bring down our first number, 2. Here we go. 1 times 2 is 2, minus the 5 at the top of the next column is negative 3. 1 times negative 3 is negative 3, minus that 17 makes negative 20. 1 times negative 20 is negative 20, plus that 41 makes 21, and we're going to have 21 minus 21 makes 0. So our function here now becomes f of x equals x minus 1 times 2x cubed minus 3x squared minus 20x plus 21. Okay, that's our new function to try and break down a little bit more. And it turns out that if we try 1 and add these coefficients together, we get minus 23 and positive 23. 1 is going to work another time. So here we go, 2, negative 3, 20, and 21. Bring down our 2. 1 times 2 is 2, minus that 3 makes negative 1. 1 times negative 1 is negative 1, plus that 20 makes 19. Wait, let's try negative 21. And then we have 0. So now we have f of x is equal to x minus 1 squared times 2x squared minus x minus 21, and that will factor, because it's quadratic, into 2x minus 7 times x plus 3. So it said find the zeros and their multiplicities. Well, here we go. The zeros are 1, 7 halves, move that over to the right there, and negative 3. And 1 has a multiplicity of 2, and the other 2 just have a multiplicity of 1. Determine the X intercepts of this graph. Well, that's what the zeros are. So we're going to have 1, comma 0, 7 halves, comma 0, and negative 3, comma 0. Determine the y-intercept. Well, when you substitute 0 into the original function way up at the top there, you're going to get 0, comma negative 21. Is this an even or an odd function, or neither? Okay, I think I need to rewrite, we've got f of x right there. Let's find f of negative x. 2 times negative x to the fourth becomes, let me write that out, 2 times negative x to the fourth. That term becomes 2x to the fourth. We then have minus 5 times negative x cubed. That's a negative times a negative, so we get plus 5x cubed. Minus 17 times negative x squared. That will become negative times positive, so negative 17x squared. We're going to have plus 41 times negative x, which becomes minus 41x, and then minus 21 like that. So now we compare this with the original function right there. If it's the same, it would be an even function. It's not the same. Is it the opposite of? No, it's not. And so the answer is neither in this case. Now we have the same exact function here that we're being asked to graph. We've already found out that 1 is an x-intercept, 7/2, which is 3.5, is an x-intercept, and that -3 is an x-intercept. We noticed way back at the beginning that this was going to be a W-shaped function. So here we go with the W coming down a ways. We don't know how far it goes. It comes up, it touches and turns around, goes down for a while, and comes back up through and up to positive infinity. If we wanted to know how far these go down, we would have to use an XY chart to get some more specifics.